All right, we say good afternoon or good morning.
Hola.
Hola. All right, scatter plots. We're talking about data with two variables. Okay, guys, what's the prefix that two usually means? What if you have a? I don't want to say what it is because that's the prefix.
Bicycle.
By, right? Two variables or pairs of numerical observations are called bivariate. That's the new word I learned, guys. Bivariate. The prefix bi means two, and variate is just a form of the word variables. We're talking about bivariate data. Two variables. A scatter plot shows the relationship between bivariate data graphed as ordered pairs on a coordinate plane. So you're going to do a lot of graphing today. You might want to use your book for your homework because your book has the graphs already done. Okay? So maybe start bringing your books again. I know I told you guys to leave your books at home, but maybe grab it tonight and bring it back tomorrow. All right, construct a scatter plot for the number of viewers who watched the new TV season of a TV show. So, season 1, you got 31 million. Season 2, 26.3 million. All the way 6 seasons of this show. Which one's the X and which one's the Y?
The X.
What do you think?
X is season and that's X.
Okay.
And then Y is viewers.
Exactly. I would, if you're not sure, go with the first column being X and the second column being Y. Because the XY is an ordered pair is arranged that way. Might as well do it that way. So your X-axis is your seasons, and your Y-axis are your viewers. How many millions of people watched it in a certain season? And if you pair those things up, it would be season, comma, viewers. Okay, we're not gonna list all those ordered pairs because they're right here in the table for you guys. Okay. I think one of the hard things for kids to do is to figure out their intervals. Let's see. We said the X-axis is your seasons. So everybody label your X-axis the seasons, and then your vertical axis, your Y-axis, that's going to be your viewers. And sometimes you got to write that word sideways, but that's okay. Okay. Let's see. Look at your numbers for seasons. That's easy. 0, 1, 2, 3, 4, 5. It only goes up to 6. So we can go by increments of 1 there. The viewers are more difficult to get the numbers on the y-axis for our viewers. What you want to do is look at your biggest number and your smallest number. Where do we start and how high do we have to go? Because here's what kids want to do. You cannot do this. They put like 31.7, 26.3, 25.0. That is, you cannot do that ever. Okay? You gotta have nice equal increments. Billy Coyne, what's the biggest number out there?
31.7.
So we gotta go a little bit higher than 31.7. Do we have to go to like 100?
No.
No, it'd be silly. Okay? What's the smallest number, Bill?
22.1.
22.1. Okay? So we could put a break in it. Okay, and that's where you kind of don't start at 0. What do you want to do, Billy? There's several ways you can do it that would all be
Put a break in it, start at 22 and go by 2s.
I don't want to know if you'd start at 22. You know, starting at 22 is weird. How about put a break in it and start at 20?
Okay.
You know what I'm saying? And guys, let's do that. Let's put a break in it, and a break is just kind of like a zigzag thing that they put starting at 0 up to where the first box is. That's called a break. And we're going to start at 20, and we need to go all the way up to 32, or maybe 35. I like to go by 5s and 10s. See, 20. Let's see, 25. If I go, every 2 boxes is 5. That might work out good here. So I'm going to go, skip the first box and go to the second box and put a 25. You could do it by 2s. You could do it by. Does it fit all the way to 32?
Yeah.
Okay, do it by 2s then. You guys want to do it that way?
If it's still 34.
Okay, good. Let's do it that way then. 22, 24, 26, 28, 30, 32, and 34. And these are in millions of viewers. There's not just 20 people watching the show. There's 20 million watching the show. That actually worked out great, guys. That was better than what we did first period. Okay? So now, everybody take their data, their 6 data points, and graph them. And just estimate. It doesn't have to be perfect. Okay? At season 1, there was 31.7. So that's right below 32. Think about that. Put a big old point there. At 2, 26.3. So right over the 26. At 3, it's 25. 25 would be right in between 24 and 26. Okay, at 4, 24.7. At 5, it's 22.6. And at 6, it's 22.1. I could maybe be a little bit higher, but it doesn't matter. Okay? All right. Do not, write this down. We had to write this down last period. Do not draw a line. Okay? And then put in parentheses, yet. Because I think eventually we will. Do not draw a line. Like, there's always one kid who thinks he's in first grade does connect the dots through that thing. Okay? Don't draw a line. Now, somebody say one intelligent thing about that data.
The show must be bad.
Angie.
It's negative.
Negative, yeah, it's got a negative trend, right? So would you agree less people are watching it every year?
Yeah.
Right.
World show. Every season.
Every
Look at the first year. Would you guys say the first year is pretty high? Yeah. Look at that compared to the rest of them. So maybe the first year must have been really good, or a lot of people
It
watched
probably
it.
came out.
And then it gradually dropped down. Okay. So that's kind of what you're doing today. Just graphing points. Your job. The hard part, I think, is making these increments. All right.
That's
All right.
the easy part.
Let's jump to the next page. You guys are doing great. All right. Construct a scatter plot of the weight of an alligator at various times after hatching. You guys know alligators came from apes?
Yeah.
That means they're not a mammal. They're a reptile. Very good. Okay. Learning some science here. Okay. They were nice to you on this one because look at your graph, people. Why were they nice to you?
They gave you the numbers.
They gave you the numbers. Look at that. Okay. They gave you the numbers, which is good. In your homework, you're going to see that. Which one is the x variable and which one is the y variable?
X is weeks.
Oh, we're going to go x, y.
Weight is
So I'm going to do the weeks down here. Label your axes, please. You always got to do that. And then the weight, you got to write sideways. Okay, and that's in pounds. Right? What's the weeks 0 pounds 6 mean?
in 0 pounds. In 0 weeks, it was 6
When
pounds.
he was in the egg, he's
I would think not even when he was in the egg, just when he was born, right when it hatched. Right when it was hatched, guys, the alligator weighed 6 pounds. Interesting. So everybody gets 0, 6. And then do your best to graph the rest of it. Go. 9, 8.6, 18.10, 27, 13.6, 34.15, 43, 17.2, 49, 19.8. So we say something intelligent about this alligator. As time goes on, he's gaining more weight. And based on our information, it never lost weight. It might have been a day or something where it was a little bit less, but over weeks, that thing gained weight. Okay, that's a positive relationship, which only makes sense. You know, only makes sense for an alligator to gain weight as time goes on. Here are your types of association. If all your points are going up and to the right, as x increases, y increases, that's considered a positive relationship. The two examples we did have positive relationships, I think. But if as x increases, the y value decreases, that's a negative association. Okay? Kind of like the value of your car over time. It's going to be a negative relationship. Car costs a lot of money the day you buy it.
Wait, but wasn't the TV one negative?
What was what?
Wasn't the TV one negative?
Oh yeah, the TV one was negative. You're right. The first example, one of them was negative, one was positive. Yes, thank you. I thought it was positive. Negative view or the viewers, that was a negative relationship. And then, guys, what if your dots are all over the place?
It's no association.
Okay, there's no association. This is a great example. What if we graphed eye color versus grades?
Oh, that'd be, it doesn't.
They don't go together. It'd be no association. Somebody with brown eyes could have good grades or bad grades. Somebody with blue eyes could have good grades or bad grades. It'd be all over the place. That'd be no obvious pattern. Now, here's something that they're going to ask you to do in your homework. Okay, if all the data kind of like consistently goes in the same direction, okay, that's considered linear. Even though it doesn't make a perfect straight line like we're used to, it'd be linear. But now, what if the data points like kind of get positive, then all of a sudden they quickly get positive? That's considered nonlinear. Okay, you're going to have examples like that. All right. There's two words we got to write down here. Cluster. Got that on the word cluster in there somewhere. That's kind of like the graph you guys did yesterday, where all the points in one small area is considered a cluster. And that's what you have to decide. Are the data clustered or not clustered? I think the two examples we did so far, not clustered.
Yes.
We spaced them out pretty good. And then the other word is called an outlier. You ever heard the word outlier before? Okay? Think of outlier. Okay, that's a very strange / odd data or point. I'll show you guys an outlier here in a minute. You guys will totally get it. Okay?
Wait, so it would be like on the linear graph, it would be like all the way on top?
Yeah. Like, see this linear? Guys, if there was one point right here, that's an outlier. Okay? If we graphed everybody's age in here, okay, I would be an outlier. Because it would be 13, 14, 13, 14, and then you'd have some 47-year-old point way out. I would be an outlier. Okay? Mr. Gracie would be out by me too. We've got two outliers. So, the outliers are very strange. A piece of data that just doesn't go with the rest of them. Forget about those. All right, jump to the next page. Okay, you're going to do a lot of interpreting of graphs. Okay? Interpret the scatter plot of the, these are very wordy questions. Listen to this. Interpret the scatter plot of the data for the time elapsed. You guys know what the word elapsed means? Like goes on, as time goes on, and the temperature of water based on the shape of the distribution. So they graphed it for you guys. Somebody say one intelligent thing about that graph that you've already learned today. Benetti.
It decreases.
So what word do we use for that? It doesn't-
Negative.
Negative association. Very good. Can anybody? Why does the temperature decrease over time for water?
Because it cools off.
Because it cools off, exactly. Think about if you boiled a pot of water, then turned off your stove, what would happen to the temperature of that water?
Goes down.
Would it go down? Would it go down like instantly?
No,
It would
slowly.
take time, slowly. Okay, that's what's going on there. Okay. Any clusters or outliers? What do you guys think? No. No clusters or outliers. That's what you guys are going to have to talk about. And the last thing is, what else did you guys learn from that first table there? Jack Muir. Linear. It's basically linear. It doesn't do a dramatic change. It's not a curve. It's pretty linear. So those are the three things I wrote down about this data. It's a negative association. There's no clusters or outliers, and it's linear. So that means it's kind of like cooling off at a steady rate. It's got a steady slope. Yeah, there's that word again, slope. Great job. All right, next one. Interpret the data for the plot, for the scattered plot of data for 2 weeks in May. Okay, so good look. It only goes up to 14 days. Notice that 2 weeks, 14 days, and the amount of ice cream sold at a shop based on the distribution.
I want ice cream.
What do you guys think? Positive, negative, or no association?
No association.
Definitely no association. Look at those points are all over the place. Okay. On day 2, they only sold 10 pints of ice cream. Okay. On day 1, they sold almost 25. On day 3, they sold almost 30. You know, day 2 must have been maybe like a Monday or a day that people don't go buy ice cream. Okay. Clusters? No. Outliers?
No.
I don't think there's any outliers. If there would have been like 1 point way up here, like 80 for the number of pints, that would have been an outlier. So, no clusters or outliers.
It's not linear.
And then it's not linear, or it's definitely, well, I don't even want to say, we could say it's non-linear, but I think we're more worried about a curve. So don't write anything else after that. And if you wrote non-linear, that wouldn't be a big deal because it is not linear. All right, last page. You guys are doing awesome. All right. Last problem. All right. If you look at the pattern of a set of data, you could make a conjecture. Do you guys use the word conjecture in science? Yes or no? Do you use the word hypothesis in science? They're the same. What's conjecture mean?
Educated guess.
Hypothesis. Very
Educated
smart.
guess.
A what?
Educated guess.
An educated guess. That's what a conjecture is. An educated guess. Read that last period too. I always think the word guess starts with a Q. I do. Every time I write the word guess, I start it with a Q.
Yes.
That's because there's a U after it. You're used to writing a QU.
I think that's right. QU. So whenever I write the word guess, I always start with a Q. But anyways, a conjecture is an educated guess. You're gonna make a conjecture down there at the last question, part C. But the table shows the number of units produced in a certain number of hours in a manufacturing plant. So over time, they make that many units. Who knows what they're making? Back in my day, they always called them widgets. You guys ever heard of a widget?
Yeah.
Some made-up thing. It was like a thing that produced widgets. I don't know what they are.
I like
It's just a thing. I like widgets. Anyways, which one's the X? Which one's the Y?
Time is the X.
Guys, time is always X. Miss Corlett tell you that yet?
Yeah.
Good. Time is always goes on the horizontal axis. And then the units produced will be your Y. So let's do time in hours
Ow.
and units produced.
It'll take 2 days.
Or widgets. Okay? And then just graph those 1, 2, 3, 4, 5, 6, 7, 8, 9 ordered pairs. Okay? Construct the scatter plot. Again, just eyeball it. Do your best estimating here, people. So at 8, it's 20. At 19, it's 41. 16, it's 28. So these ordered pairs, guys, are not in order of X or Y. They're randomly. So at 40, we got 60. It's an easy one to graph. 34, we're at 49. At 8, back to 8, we're at 28. At 40, we're back to 63. 19, we're at 40. Right there, and then 34, 58. Okay. Everybody write down a few things you know about that scatter plot.
It's positive.
Positive. What else? Linear. Definitely. It basically forms a line. It's not perfect. It's not exact. Are there any outliers or clusters?
No.
No. No clusters. No outliers. Okay? So you guys said all the important things you need to say about that data. Okay? Now, here's our conjecture. Here's our hypothesis. Here's our educated guess. Don't say it out loud. There's not one right answer here. You can be, as long as you're close, we're happy. How many widgets are we going to make in 50 hours? Write down a number. How many widgets are you, based on this info, based on your graph, in 50 hours, how many widgets are you going to make? Raise your hand when you got an answer. There's not one right answer. As long as you're close, we're happy. Shushko, how many widgets are you going to make in 50 hours? 75 to 80? 75 I thought was good. 80 might be a little bit too big. Anybody have a different number? I had 70 written down. Anybody else have a different number? 70 to 75 is perfect. They said 65 last period too. They said 60. I think that would be good. What if you said 10? You're way off. What if you said 190?
That's impossible.
That doesn't make sense, okay? You're looking at 50, and you're going up, and just put a dot right, because, you know, you're trying to extend your line. It should be about 70. Okay? That make sense? All right, your homework, guys, is on the team website. It's also written over there. And what time do we get out of here? 25? Oh, you got 10 minutes, guys. Everybody get 5 problems done. Go.
Mr. Casey.
Go ahead, Harrison.